In this video, we are going to write our own harvest collector in Python. There are 4 things we will do. First, we choose a name for our collector, obviously. We create a subfolder and a Python file for our collector using this path. Both should use the name of our collector and be lowercased. We edit the file, we define a class and inherit the abstract collector class of Harvest. Then we write a method named pollData that takes no arguments and returns a data structure that I will describe shortly. Final step is to create a template file with the basic configuration of our collector. And that's all. After these 4 steps, we can actually run our collector. As a practical example, I will write a collector that counts the number of lines in Harvest source code. But before we start, a little bit more about step number 3. We will work with a data structure called the matrix. This is a slightly complex and highly optimized 2-dimensional array with some hash tables, and it's used by all Harvest components, collectors, plugins, and exporters. But for starters, there are really only a few methods that we should be familiar with. First, we initialize the matrix in dynamic mode with a pointer to our collector. We initialize the counters that we want with the addCounter method. The first argument is the name of our counter. We initialize our instances. Instances are the objects that our counters describe. So, in my toy example, that will be the files in Harvest source code. The first argument here is the instance name, which can be followed by any number of labels as keyword arguments. One thing to keep in mind is that counter and instance names should always be unique. Otherwise, these 2 methods will throw a value error. The lost method, setValue, is what we will use to add the actual numerical values to the matrix. Okay, so let's get started. Okay, so first I will create a directory for my collector and a Python file. I will define a class, that's my collector. I can use uppercase here, CodeHunter is the name. Let me go ahead and import the abstract collector class and a matrix. This is the way I will do it. So this should be a function that returns a matrix. There we go. Okay, so next I will declare a counter, addCounter, and my counter will indicate the number of lines in a Harvest file. So let's say line count is the name. Then the second thing is to add my instances to the matrix. And for that I will use the OS library from Python. And I think I have to do 2 iterations. I will use osWalk, and my abstract collector class gives me this attribute, which is a path to my Harvest directory, so I will use that. And this osWalk gives me 3 elements. That's the directory paths, the subdirectories, and the files in each directory. And for my second iteration, I will iterate of file names in the list of files. And now I could use a file name to add my instance, but file names are not unique, so I should get a problem there. So I will use the full file path. Also, I think path join. That will be the directory path and a file name. Now I can add my instance. Data, add instance. So the file path is the name of my instance. And actually I also want to add some labels. Let's say I am interested in the language of my file, and I will use the extension of the file name. So let's say if it's a .py file, I will use py, and then I will know that it's a Python file. So this should give me whatever is after dot in the file name. Now I will add a keyword argument. I will say I want a label called language, and the value is the value of the variable extension. Perfect. Last thing, I will now count the actual number of lines in my in each file, and I will do it the dirty way. So there are a few files in my Harvest directory which are binary or image files that I shouldn't be able to read. So those I will just ignore. Number of lines is f or len, read lines. So should get, I think, an os error, but this is the dirty way, so I don't care what the error is or the exception. So if I did get the number of lines, I will say data set value. First argument is my counter, second argument is my instance, and third argument is my numerical value. Lines. There we go. So actually let me define one more counter. Let's say I also want to know when the file was last modified, and I will just use the same function. This is modified, and I will use the os library again. Well, I think it's ospot get mtime, and this would get file path as argument. There we go. Can also throw a log message. Again, this comes with my abstract clause. And I think we should be fine here. Last thing is to create a template file. I will do it very quickly, but I will give you detailed explanation what actually the template file does. So I will have name, code hunter, that's the name of my collector. Object is anything that I want that describes what my collector is collecting. This is important. I will have only one poll, which is data poll, and I want to run it every 10 seconds. Lastly, export options tells my exporters how to export the data. And here I want to make sure that the Prometheus exporter actually includes the label language in my metric. So I will add a new poller with my new collector. Let's say I name it dev. Hopefully this is fine, and I will use this default list of exporters. I will use Prometheus. Let's go ahead and see if that works. Tail log dev. Seems like we are fine. Let's check it out. Okay, so this is nice. You can see that I'm getting the two counters that I defined. So let's take a look at the actual data. Yeah, seems fine. One more thing, let's see if we can actually quickly add a few dashboards and graphs in Grafana and display our counters. So let's say I want to start with the first counter that we created. And what I want to see is the total number of Python lines in my Harvest source code. So you can see that this language label is really very helpful because I will filter out and keep only Python files. So I can see I have roughly 20,000 lines of code. Let's say I also want to see the total number of lines of all readable files in Harvest package. In that case, I will just simply remove this guy here. Write 300,000 lines of code, of course. And this is Python. What I also can do, I can use this metric here. And let's say I am interested to see the last modified 10 files in Harvest. So in that case, I think I will use a table instance. Something is wrong, top K. Perfect. And yeah, I just want to filter out anything that's not important. So you can see the last file that I have changed is this collector that we just wrote, which is correct. Yeah, that's nice. So there we go here. I will add one more graph, but before I do that, because I want to see the change in lines of code real time, I will just go ahead and let's say I will just add some redundant lines here. Let's say I have a comment here. This is my first collector. I will just duplicate that. I want a lot of lines. There we go. Let's see if we can get that reflected here. So I will make this a bit larger. So that's a graph. Source code, line count. Yeah, and here my label will be source code. So that's the name of the file. Everything else is correct. There we go. So that's what I wanted to see. So that's nice. Now we can display our counters.